Hello everyone, so in this video we are going to talk about Jupiter, the largest planet in the solar system. So first of all we will see why should we at all talk about this planet. So Jupiter is believed to be the first planet to be formed when the solar system was just forming, and because of that its composition is similar to that of our Sun. Now it is also the largest and the most massive planet in the solar system, but it is not massive enough to be a star. It also played a key role in shaping the orbits of the other bodies, since it was the most massive object then and now. So this is an image taken by the Cassini spacecraft, and if you look closely there is an interesting feature here, that is this dark circle, which is actually a shadow of one of the Jupiter's moon. Okay, so as we all know, Jupiter is the largest planet in the solar system. It is also the fifth planet of the solar system, and it takes about 10 hours to rotate around its own axis. It takes about 12 years to complete one revolution around the Sun, and the axial tilt is only 3.13 degrees, which is very small, and hence seasons on Jupiter are not very severe. Okay, so now how is it different from Earth? So we are going to compare the values with that of Earth. Mass of Jupiter is around 318 times that of Earth, whereas the diameter of Jupiter, or the radius, is around 11 times that of Earth. So along the diameter of Jupiter, you can actually place 11 Earths side by side. Now density of Jupiter is almost equal to that of water, that is 1.33 gram per centimeter cube, whereas the escape velocity at surface is 59.5 kilometers per second. Now as of now, the number of satellites of Jupiter, the natural satellites of Jupiter, is 95, which are officially accepted by IAU. Now let us see the composition of Jupiter. So as we saw that it is mostly made up of hydrogen and helium, and there are also some other compounds like methane, water, ammonia, and this content varies in different layers. The outermost layer is obviously the atmosphere, which is made up of mostly hydrogen and helium, and it is the largest atmosphere in the solar system, which is almost about 71 kilometers. Within the atmosphere there are actually three layers. The topmost layer is made up of ammonia ice, the middle layer is that of ammonia compounds, and the lowermost layer is that of water, ice and vapor. Now as you can see in this image, there are various bands on Jupiter. The darker ones are called belts and the fainter ones are called as zones. So these zones are actually colder as that of the belts, and also these belts and zones, they rotate in opposite directions. So that was about the atmosphere. Now beneath the atmosphere we have the outer interior. The temperature of this layer is little bit higher than that of the atmosphere, and it comprises of liquid hydrogen and helium and some other compounds. Now beneath the outer interior we have the interior. The temperature here is higher than the outer interior, which is why now here the liquid hydrogen is actually now metallic hydrogen. So the temperature is so high that the electrons inside the hydrogen atom are squeezed out, and this layer is also conductive. So we saw that Jupiter rotates faster than that of Earth, roughly 10 hours. So because of this rotation there are various currents that are set inside this layer, which is responsible for the strong magnetic field of Jupiter. Beneath the interior we have core, and we are not yet sure if it is liquid or solid. All we guess is that it is made up of hot dense soup of iron and silicate minerals, and the temperature is expected to be as high as 50,000 Celsius. So let us come to a very interesting feature of the Jupiter, the great red spot. Now as you can see in this image, you have a red circle like thing. So this is actually elliptical shaped anticyclone, and it is located at 22 degrees south of the equator of Jupiter. It is also the largest storm in the solar system, and it is about 16,000 kilometers in width. So you can almost fit one entire Earth inside that storm. The winds there are moving with very high speeds, At the edge of the storm here, you have winds going as high as 432 kilometers per hour, and it is expected to have been existed for more than 300 years. So the first observation of this spot was made in about 1660s, and yeah. To complete one circle along the surface of Jupiter, this storm takes about 4.5 Earth days. So we initially saw that the speed of rotation of Jupiter was around 10 hours or so, but now the speed of rotation of this particular storm is 4.5 Earth days. So which also tells that different layers of Jupiter rotate at different speeds. So Jupiter is not a solid sphere, it is made up of gases, and hence different layers move with different velocities. It is also said and observed that this particular storm is shrinking in size. So when it was first discovered, the width was thrice that of Earth, and now it has shrunk to about the size of Earth. So coming to the magnetosphere, so magnetosphere is the region around the planet which is influenced by the magnetic field of that planet. Now Jupiter has a very strong magnetosphere, it's about 16 to 54 times that of the Earth, and the reason we have already spoken about in the composition of the Jupiter. It extends to about 1.3 million kilometers towards the Sun, whereas in the opposite direction it tapers and it extends up to 1 billion kilometers, that is roughly till the orbit of Saturn. Okay. So particles from the solar winds get trapped in this magnetic field, which lead to a very interesting phenomena, aurorae. So like Earth, Jupiter also has aurorae on both the poles, but these are very huge in size compared to Earth. They are 100 times more energetic as well. But unlike those on Earth, these aurorae, they never cease to exist, they are always there, and the reason being the source is not only because of the solar wind, but it also attracts particles in the neighboring space as well as particles that are ejected from volcanic eruptions on its nearest moon Io. We already saw that there are total 95 officially recognized moons of Jupiter as of now, but this number keeps on increasing because Jupiter is a very massive planet and it keeps attracting nearby asteroids. The 4 moons that were discovered earliest were discovered by Galileo, and these were Io, Europa, Ganymede and Callisto. So Io is the nearest moon and it is also the most volcanically active moon, whereas Ganymede is the largest moon in the entire solar system. So on your left hand side top, you can see Jupiter at the center, and there are 3 of the 4 Galilean moons, that is Io, Europa and Ganymede. Now these are moving with particular speeds, and if you see closely, when Io completes 2 orbits, Europa completes 1 orbit. So Europa is in 2:1 resonance with respect to Io, whereas Ganymede is at 4:1 resonance with that of Io. Now we already know that Io is the 3rd largest moon in the solar system. It is also the hottest moon in the solar system and the most volcanically active one. It is also tidally locked to Jupiter. So same side of Io is always facing Jupiter as it goes around its orbit. Now because of this, what happens is the gravitational pull on the side which is facing Jupiter is higher than that of the opposite side. So this leads to distortion in the shape of Io. Another factor which plays an important role is that the orbit of Io around Jupiter is not circular, it is elliptical. So this force which pulls the front side of Io, it also keeps on changing, and hence the distortion itself keeps on changing. So this leads to friction between the layers of Io, the internal layers of Io, and it leads to heating, and this is why Io is the most hottest moon and also responsible for the volcanic activities on Io. So rings of Jupiter. So Jupiter does not have very dense rings and they are not visible through telescopes from Earth, but it does have very faint dispersed ring around it, and it was first discovered in 1979 by Voyager 1 spacecraft. These rings are formed because of the meteors in the space around Jupiter. They sometimes impact on the innermost moons, and which is why there is some dust and some small particles which lead to the formation of the ring. So this is a picture of the space mission Galileo, which was launched on 18th October 1989. Before Galileo, there were actually 3 space missions which have visited Jupiter in the form of flyby. The first one was Pioneer 10 and the next 2 were Voyager 1, and Galileo was the first spacecraft which was sent to orbit an outer planet, which is why it is important. And it also changed our view of the solar system. It also directly observed a comet colliding with that of the Jupiter's surface, that Shoemaker-Levy 9. Apart from Galileo, we have a space mission called Juno, which was launched in the year 2011, which studied Jupiter's atmosphere, gravity and the magnetosphere. We also have JUICE, that is Jupiter's Icy Moon Explorer, which is still working, and it was launched in 2023. And we have a mission planned, that is Europa Clipper, which is to be launched this year, that is October 2024, which will study one of the Jupiter's moon, Europa. Jupiter also acts as a great lifesaver because it protects the Earth. It acts like a vacuum cleaner. It either sucks in many of the asteroids or it deflects the orbits of comets and meteorites, which otherwise would have hit the Earth directly. So this is again an image taken from the Hubble Space Telescope of the impact region of Shoemaker-Levy 9, and this region is about 2,500 kilometers in diameter. That's all from this video. Thank you.